Welcome to Sangeet I, an AI-powered system that detects your mood and plays a corresponding Indian classical raga to uplift it. Indian classical music remains the richest artistic tool, training, and performance system in India. It is a cultural anchor for millions of children. It instills in us a collective belonging, shared identity, and spirit of secularism. However, it is fading and it is hindered by systemic barriers. These include high costs of learning, which can be up to thousands of dollars a year. Additionally, resources and performances are often concentrated in cities, leaving rural areas underserved. Of the 354 million children in India, less than 1 in every 1,000 receives access to musical training. My goal is to use AI to democratize access to the arts in a manner that is free and readily available for Indians across the country, to empower thousands of young children to continue this craft, and to provide an uplifting experience for individuals of all ages. The project is an AI-based system that performs sentiment analysis to scan your face in real time and detects your mood. The model is a multi-classifier created through convolutional neural networks. It identifies 5 core emotions and tailors the experience based on your current mood. Based on your mood, the system plays an appropriate Indian classical raga to enhance your emotional well-being. While you listen, the system provides insightful information about the rag, enriching your experience and understanding. Sangeet I's ethos lies in accessibility. Anyone and everyone can access the system for free. It is available in public parks and spaces across India. All the user has to do is scan the QR code on their smartphone and it will directly link them to Sangeet I. Sangeet I is unique because it is the first of its kind platform to blend deep learning technology with Indian classical music, creating an experience where artificial intelligence interacts directly with the user's emotional state for free. The use of AI to select ragas based on emotional states introduces a novel intersection between art, AI, and mental health. This makes the experience both cultural and therapeutic. AI is necessary because it enables the platform to analyze emotional states and select ragas in real time, offering a highly personalized experience. CNNs excel at analyzing facial expressions and correlating them with emotional states. And by bridging advanced technology with an ancient art form, AI creates a platform that resonates across generations, bridging divides between the tech savvy youth and older audiences familiar with Indian classical music. Our model is ethical because it processes video frames locally without transmitting or storing personal data. By training the model on a balanced and representative dataset, it minimizes the risk of biases. Users are also informed when the emotion detection system is active, respecting their autonomy and right to choose. The system is designed to enhance human experiences without replacing or devaluing human interactions. Sangeet I revitalizes Indian classical music, making it relevant to younger generations and ensuring its survival. It creates a bridge between traditional knowledge and modern technology. And by using ragas tailored to emotional states, the platform provides therapeutic benefits, potentially helping individuals manage anxiety. The project also inspires young women and underserved communities to see the potential of STEM in driving social and cultural change. And as a digital first solution, the platform reduces the carbon footprint associated with live events. Sangeet I is completely free. Pause to read about our future plans. I hope you enjoyed. Thank you. Welcome to the technical video of Sangeet I. The dataset we used included 3,927 images across 5 classes: happy, sad, surprised, neutral, and angry. It includes individuals that identify as Caucasian, African American, South Asian, East Asian, and even Latin American. As for data preprocessing, we employed a train test split, converting the dataset into 2,709 training images and 1,218 test images. We also employed grayscale conversion and resized our images into 48 by 48. Then we performed batch normalization and finally data augmentation via the image data generator for training. The architecture that we used was a convolutional neural network. This contained many layers. The first was a convolutional layer, which had different sets of filters that helped to capture increasing levels of abstraction from edges to more complex patterns. We also had the pooling layer, which reduced spatial dimensions, and the dropout layer, which prevented overfitting by randomly deactivating neurons. In addition to this, we performed batch normalization to normalize activations and stabilize training, which would help improve our convergence speed. And we also made use of the rectified linear unit activation function to introduce nonlinearity, enabling the model to learn complex features. Then we had the fully connected layers, which include the flattened layer and the dense layers, which used a softmax activation function to classify emotions into the distinct categories. As for training, the loss function that we employed was categorical cross entropy, since we had multi-class classification. Our optimizer was Adam with a small learning rate to ensure smooth weight updates. And to evaluate our model performance, we used accuracy as our metric. And finally, the Streamlit application helps us to integrate the train model with a real-time video stream using OpenCV. We used OpenCV while building the software, and we used WebRTC when deploying it. Frames are processed every 120 seconds using WebRTC, with the datetime package controlling frame intervals. Detected faces are resized, normalized, and fed to the CNN. Once a prediction has been made, that specific emotion maps to a specific Indian classical raga via a dictionary. Asynchronous music playback uses multi-threading, ensuring uninterrupted video processing. In addition to this, based on the raga, information about it is displayed through dynamically changing HTML. This is how it works. All you have to do is hit start detection to begin your experience. Once your face is scanned, the emotion is detected and displayed. In addition to this, a corresponding raga is displayed. You can listen to this for as long or as little as you like. Then you are given the history and the musical knowledge behind the raga. You can stop detection whenever you like, and you can restart detection as many times as you like, whenever, wherever, however. Thank you, and I hope you enjoyed.